Hello, Maya and Casey. Hi. And maybe that's it. Hi. Hey. We are doing some more graphing things, and we're kind of incorporating 7-1 stuff into this section, because when we graph cosecant, secant, cotangent, what we're going to do, at least for cosecant and secant, we're going to graph their respective other value, right? Cosecant goes with sine. Write this at the top. Cosecant and sine go together. When you graph cosecant, you are going to graph sine first, okay? When you graph secant, you are going to graph cosine first, okay? When you graph cotangent, you are not going to graph tangent first, because they are a little bit different from one another. So, but just keep in mind that tangent and cotangent will be similar to each other. But these two, right here, when you graph cosecant and secant, you will be graphing sine and cosine before you graph them. Here is the deal, okay? This is what the graph of cosecant looks like, okay? Take note of this dotted blue line. I'll make him blue or purple. Sine. This is sine, okay? And this is the graph of what sine looks like. And when you go to graph cosecant, all you do is you find the middle points. You see the middle points of your curves? Halfway between the top and the bottom. And you connect a vertical asymptote through each one of those dots. Those middle dots right there, you do vertical asymptotes. And then he is just going to do like little parabolas off of the highest and lowest point. Okay? That is what cosecant will look like. The graph of cosecant, you graph sine first. And they're going to touch at each one of those, points. And he has vertical asymptotes that confine each one of those parabolas. Does that make sense? That's what he will look like, okay? So let's go down and let's graph 3 cosecant, okay? Which one goes with cosecant?
Sine.
Sine. So we're going to first graph -3 sine of t. We practiced doing these yesterday, but let's talk through and say, what does the negative do and what does the 3 do?
The negative is...
The negative flips it. So I'm going to say reflect. And the 3 changes the amplitude. Okay, which is a vertical stretch. It's going to stretch it out, make it taller, right? Okay, Cray. Listen, write this down, okay? All right, so we're going to graph sine, and I'm going to start by labeling, and I'm going to go to, let's do 2 periods. Let's go 2 pi is here, and let's go 4 pi is here, okay? We're going to do 2 full periods of sine, okay? That means the halfway point is pi, and this is 3 pi. I'm trying to make him like the same units apart, okay? I'm also going to put little hashes in here. These are the pi over 2s, or the 3 pi over 2s, or the 5 pi over 2s, or the 7 pi over 2s, right? Those guys. But I'm not going to mark them, okay? And let's just go through and do our dots. What?
Did you ever consider becoming an architect?
You know, I don't know. Sure. I ponder lots of things on days that I hate teaching, that like, why didn't I do this, right? But I don't know if an architect's ever one of them. Yes, it is your fault. Okay. All right, starting with, where does sine start? Does it start at 0 or does it start at 1? It starts at 0, okay?
What if I wanted it to start at 1?
Well,
now, my amplitude is not 1, though. It is 3 this time. So I'm going to go up 3, down 3. I'm going to label 3 and -3 so we know what our amplitude is. And instead of going up to 1, we're going to go up to 3, but we're not going to go up to 3. We're going to go
2
down to 3 because we reflected it, right? Okay, so this spot right here, that middle point is going to go down to 3. Then we're back to center. Then we're up to 3. Then we're back to center. You see my 5 dots where he curves. Okay, now I'm going to do it again. I'm going to go down to 3, back to center, up to 3, back to center. There are my 2 full periods of sine. And that's what he looks like. Okay, I did 2 full periods, 2 full like chunks. Okay, very nice. All right. Now what we're gonna do, we're not done yet because we have to graph cosecant. But cosecant, after you have this done, is ready to go. I need to put my vertical asymptotes in there. Your vertical asymptotes are gonna be at all of these places where he's in the middle, right? In the middle of your curve, like in between the highest and lowest point where he touches that middle line is where your vertical asymptotes are going to be. And all you're going to do is just do these guys off of them, okay? this one, and this one, and this one,
JB.
and this one. Okay? That is your cosecant. That's what he looks like.
I get out of Kim.
Me too. I get a
Art.
study.
And I
Yeah.
need to be an art.
All right, did you get that one done?
Yeah.
All the way through, yeah?
That one was
Okay, now, secant is exactly the same thing.
Yes!
Yes, we love it. So,
Except-
it's just you graph cosine first for secant. So, cosine looks like this. And again, yep, you start at 1. So, like, here's your y or your y-axis, and he's up at 1. Okay? But your vertical asymptotes are in exactly the same spot. Like my middle line, my middle line, my middle line, those are where my vertical asymptotes are. And it's it's exactly the same thing.
Did you throw that at me?
Your little parabolas are going to be confined in between those vertical asymptotes. So all you're going to do is graph cosine. What? These guys.
Parabolas are those
These are your secants.
secants?
Secants, right? Because secant and cosine go together. Right?
Okay, yes. I
They
get
they
that.
do little half ones over here because he stopped halfway through. But anyway, whatever. Okay?
Okay.
All right, so let's do 2 secant of -3. So let's go through and label this stuff. What is the 2 doing? Oh, yeah, we're going to do 2 cosine of t minus 3. What's the 2 do? It makes the amplitude 2, or it's a vertical stretch. It's making it taller. And what's a -3 do?
Moves it down.
Moves it down 3. Which one do you start with?
Down.
I always do the down 3 part first,
So it's gonna be
right?
-2. I know
So,
that.
down 3. 1, 2, 3. And I draw...
Starts at 1.
Yeah.
I draw a new little dotted line at -3.
Facts.
Okay? So pretend that this guy is not even here anymore, right? That's not even there. Pretend that he's not there. This guy starts at 1 because we're doing cosine, right? So 1 would actually be like here, right? If it's 1 above, it would be there. But, hold on. My amplitude is not 1 though.
2 now.
It's 2 now, so I'm going to start 2 above, right? Okay? Now, hold on. Before we go down and up and all that stuff, let's label. Here's my 2 pi. Here's my 4 pi. Here's my 3 pi. Here's my pi. Get them all spaced out. And when you make those tick marks, it makes it so you don't have like unproportionate curvy things, right? So by doing that and making it evenly spaced, it makes it really nice for you. Okay? So I'm going to start here. Here's my first dot. My second dot will be at pi over 2, which we don't have labeled, but we have a tick mark for it, and it's going to be back at that midpoint, right? And then at pi, we go down to
Oh, yes, because it's right.
-4.
-5, right? So we're bouncing in between -1 and -5 because our amplitude is 2 and we're down 3, right? So we're going down to -5, back up to center, up to -1, back to center, down to -5, back to center, up to -1. Holy cow. You didn't get that at all. Okay. I went fast.
What we have to do is these humps.
Wait, why do I have 2 dots in one place?
I don't know. I don't know. Okay? So that's what he will look like. He bounces in between -1 and 5. If it helps you and you need to do this, make a dotted line here that goes all the way across at -1 and -5. It's kind of like when you're in like first, like Layla brings these home all the time. She's in first grade. They're learning to like write with capital letters, lowercase letters, so they stay in between the bottoms and in between. Like this looks like this right here looks like you're writing letters out. You know what I'm talking about? Okay. So use that to help you. Okay.
Yeah, I thought I was Kellen yesterday.
Oh yeah.
She saw
Nice.
me. Well, got out of weights on walk by. She goes, Kylie, I just saw Kellen.
Oh, that's funny. She's something else.
Look, Kylie, I think
She's something else. She's something else. Okay,
My dad.
now, last thing, where do the vertical asymptotes go?
The half pies.
Where the centers are, right? Like the center of your curve, right here, and right here, and right here, and right here. Okay, so I'm going to do my little parabolas off of that. It's going to come down, touch that one point, and go back up. Whoop. Come down, up, touch that one point, go back down. This guy. Now, we do them on these little half curves right here, but he's just going to do like a half of a parabola on that side, right? And same thing over here, a half of a parabola over there. That was not very good. Let me do that again. Zoop. There we go. So, those are just going to be halves. Do you see my little halves over here? Because he ends on a half of a curve, yeah? Yes? Okay, beautiful.
Yeah, you wish you could do it.
Okay? All right, now, let's go through a step-by-step homework assignment and like just go through the instructions and see what it's doing. Okay? You can do these.
Transformation.
Okay, number 1, 2, 3, list the transformation. What do I want there? Tell me where it's going. Like, what does the 3 do and what does the -2 do? That's all I want. Vertical stretch by 3,
And down 2.
down 2, that's all I want, right? Okay, now we haven't talked about number 2, but what's the +3 do?
It left.
It's in the inside.
Uh-huh,
so it was
left.
Yeah.
Plus means left, right? So that's left 2. Yeah.
Why did she
I was
say
thinking.
Wait,
Left
so
3.
5 still makes it go up.
5 still makes it go up because sometimes they're mean to you and they put the 5 there, but I always like to put the 5 at the end, right? So up 5. Okay? And what's this one do?
Got 5 left.
Reflect and
Vertical.
vertical stretch.
Vertical.
Reflect and then vertical stretch.
Reflect and vertical stretch by 4. That's all I want for 1, 2, 3. Write those down. Write those down. This is your homework.
I already know that.
Okay, great. Write it down.
Reflect,
Okay.
vertical stretch by 4.
All right. 4, 5, 6, you're doing the opposite.
Oh, it's backwards. It's 2. Compression. And
Yeah.
It's on the inside.
It is.
What do you mean? A horizontal compression, we won't.
It's flipped.
What do you
It's
mean?
vertically compressed.
Yeah, we won't do any horizontal compressions
So
yet.
it's 2.
We won't do any horizontal compressions yet.
So it's 2.
No, but you don't flip it on vertical.
Oh, that's half.
No, yeah, that's half. Okay, so 4, 5, 6 are the exact opposite. They want to compress it vertically by 0.5. So you can either put 0.5 in the front or they're wanting to use 1/2, right? So 1/2 cosecant of x and then shifted 1 unit up.
+1.
Plus 1. Yep,
Whoa.
So on 5,
Okay.
do we just say minus half? that?
minus pi over 2
Okay.
in parentheses. Yep, okay. All right, and keep a-going. Keep going. Don't do 7, 8, 9, 10 because we don't know what cotangent looks like, but you can do 11, 12, 13, 14, and you can do 15, 16, 17, 18, and you can do 19 and 20. So the only ones you don't need to do are 21 and 7 through 10, but otherwise do the rest. You have a start.
Do we just point
You get
11
going.
through 14 to the line?
You literally did this.
I just would do like A, B, C, D. Okay, now 11, 12, 13, 14.
Oh, it's on the back.
11, 12, 13, 14. They only have 2 graphs, which means you're going to use 2 of those graphs twice. Because in some cases, reflecting over the y-axis is the same thing as reflecting over the x-axis. So you'll play around with that and see what that looks like. So 11, 12, 13, 14. Take a look at the cosecant graph and what you're doing to it. Okay? So skip 7 through 10 and skip number 20. Otherwise, do the
Wait.
rest.
Wait, we're skipping what?
You mean
7 through 10.
You mean 21, not 20.
21. Skip 7 through 10 and number any of them that have cotangent. 7 through 10 and 21 you can skip. But don't cross them off because we'll do them later.
Like on
Okay?
14,
Okay.
So like on 14, yep. What?
what's the negative inside do?
I have a question.
Flips it like this way. The other one flips it
So
this
it'd be
way.
the same thing.
What?
If it's like flipped across the y.
It depends on what it looks like to start with. Like
Oh.
cosecant is the opposite of sine, right?
Yeah.
So sine does this, right? Whoop.
Yeah.
Or like this on the other side. So cosecant.
So
So cosecant does
A.
this and this and this and this.
wait.
Yeah.
So if I flip it, if I flip it over the y-axis,
Oh,
it's going to actually go here, here, here,
Yep.
here, right?
Is number 5.
But then if I take that, hold on, Clayton. If I take that and flip it again over the x-axis,
Ah.
it's going to go back to
How it was.
the original, right?
Yeah, 19
Does that make sense?
Wait,
You
so
flip it.
14, is that it, A?
So no, 14's B then.
No, 14's A.
Oh yeah.
Because
A.
it's going to go back to the original. If you flip it and flip it again,
A.
it actually takes it back to the original function.
What's
So
11?
it's 13.
13 is also
Okay?
A.
All right, there you go. You got it.
So
You
then
got
the
it.
other two
Keep
B.
figuring it out.
Yes.
BB.
All right, goodbye, people in the video.